In order to understand object-oriented programming, as with pretty much any other subject in programming, we have to start with data structures. In his famous quote, Linus Torvalds said that bad programmers care about code, while good programmers care about data structures. So let's imagine that we are writing a game that needs a fighter, and we have to somehow represent the data for that fighter. So let's forget if you know anything about classes and whatnot in PHP or any other language. Just forget that, and let's say that all you know is arrays, and and this is how you would probably represent the fighter data in your game. You would have like a name, level, money, and strength. And you would try to make sure that every time you pass this fighter along, he always has the name, level, money, and strength, because you might always want to use that. So actually, PHP arrays are too dynamic to represent this because they can change a lot at runtime. You can add and remove keys, and also they kind of provide a bit of an overhead, and you would actually be very surprised how much work it takes to implement a dynamic array that accepts keys and acts like a hash map in any other programming language that doesn't have this from the get-go. So let's go back to the 70s and imagine that we are doing this in C. So here is a C data structure for our fighter. He has a name, level, money, and strength, the same thing, but now we guarantee that it's always present, because a data structure is pretty much like a PHP array, just with keys that are enforced, hard-coded, and have to be of a particular type. So let's switch back to PHP now, and say, all right, now we have to have some functions that do something to the fighter. So let's say we want a function that does this, like let's try to level him up. I'm sorry. Level up. I'll be writing C too much lately. All right, fighter level up. Fighter. So now we want to have a function that levels up our fighter, gives him an additional level, and it's very easy to write because all we do is this here. We increase the level key by 1 and return a new fighter, and now we modified the data structure. We got a new fighter who's leveled up, and we can program a lot of this in this way. In fact, a lot of people do it like that using C. So for example, let's look at another method. Let's say fighter attack, which is going to tell us how much damage the fighter does, or like his attack score, which is also very simple. We accept the fighter, we get his strength, and we add like a random number between 1 and 20 to represent a dice roll, and that's it. So a lot of applications can be actually programmed in this way, and people programming in C pretty much do this all the time. They define a data structure, and then they define functions that operate on that data structure and then pass it along. So C is there are people thinking that C is like an old dead relic language, and it is very much not. For example, your Git that you probably use every day is written in C. There's actually been a long holy war with Torvalds who bashed developers who tried to suggest them writing it in an OP way in C++, but that's not really that related to this. So now let's imagine we have a wizard. All right. So what would the wizard be? I'll just move this code along. A wizard would have also name, level, and maybe instead of strength, he would have like magic, and he would it would be like magic power. Sorry, I have to indent everything nicely. 7, and then he would also have a mana pool, so that he cannot like cast stuff every day, and let's say 70% of that mana pool is left. So he's not going to be Yendros, Gandalf, I guess. And it's a wizard, damn it. So now we have two data structures, and we start to think, hey, I also need to level up my wizard, and although his attack would probably be calculated differently because now he has like two characteristics that would influence that, but I still want some things like, let's say, leveling up and adding money, and maybe buying items to be like generic. Well, then we need something to operate on that. And what we would do a lot of times in PHP, we would just say that we would make a function called character level up, which would take a character and do the same thing as we did with the fighter. So I'm just going to scroll real fast. All right. So now that we have this function that works regardless of whether it's a fighter or a wizard. But the problem here is, what is a character? You know, because implicitly we thought to ourselves, all right, a character is going to be something that has a name and a level. But a different developer can come to this code like later on in the future, and even though this code works correctly, he will just not know what you meant by a character, and it's going to be really hard for him to debug because he now doesn't know what's a fighter, what's a character, and what's a wizard, and how do they end. It's really much easier if those are intuitive things like fighter, character, and wizard. But imagine you have like a factory, abstract factory, and stuff like that. It's just not intuitive. So what people would do in C, and we'll be doing this still with arrays, we'll have another structure defined that would have all the common stuff. So let's say here we would say like fighter character, like this, and we would copy some information from the fighter, which would be name, level, and money, and put it in the fighter character. And here we would have character fighter character, and then we would do the same thing for the wizard. Alright, a second. Let's copy paste it as hard. And yeah. And character, wizard character. Alright, so now when you want to level up, we would write something like this. We would say $wizard character equals character level up wizard character. Alright, so now we have separated the character logic from the actual class specific logic, and we can use the same function to level up both the wizard and the fighter. But we already see the small problem here, that we have to remember the path or where the data structure for the character information is within a wizard. It in order to be writing a code like this. Okay, character. Damn it, embedded typing. So the first thing people thought was, what would be awesome if we could somehow bundle these functions that we have, like the character level up, with this the actual data structure, the fighter character. So in this way, instead of doing all this, we could have just like wizard character. Come on, type. Level up. That would be awesome, right? Because then the rest of the code doesn't have to know about it. And that actually was one of the first thoughts that drove people towards object-oriented programming, because the idea that the functions that operate on some data could be bundled with the data was so much good at the time, because it meant that even like when reading documentation, when you would look at some data structure, let's say like you're looking at a wizard, you would immediately see all the functions that are applicable to that wizard. So writing code like that was a good idea. So and then a lot of programming languages started to approach this problem, and they did it in numerous ways, and I obviously won't cover all of them. I just do, for example, the Go, the new programming language, which is really gaining momentum, is pretty much very close to C. You define data as a data structure, and you define functions like we did here. But then you can apply these functions directly to the data structure. So even though we would define a function similar like to our character level up, which would be separate from the data, we could still call it on the object itself, which is very nice because it means that functions can be defined in different files. Some languages took a prototype approach, which is JavaScript, and it's actually what we are going to look at next. And then there is PHP, which is going to take a look at. So let's look at the fighter. So this is like a data structure with a fighter in it. So yes, he doesn't have the. Let's imagine he still has the level money and strength here. So now we want to add the attack here. So let's say that attack is a function that returns I'll just write like rand one. You don't have like alright, math random times 20 something. Alright, I'll round it to a second. Doesn't really matter. Alright, let's imagine something like that. So now we have an object that has some code, and it has some data bundled with the code. This looks nicer because, and that is how a lot of people develop in JavaScript, but this is nicer this way. This actually lets us see like everything in this nice one place. So so let's talk about actually separating the character data. Well, to do this, JavaScript has a very awesome feature, which is prototyping. Prototyping is, let's say, I have a var character. I can put all these non-fighter related things here. Like I put them there. And then to the fighter, I say that its prototype is character. So now the methods that I add to character are going to be immediately available for the fighter, which is nice. So it allows us, very similarly to how we do with arrays, we in JavaScript we can build objects and functions in this very nice fashion. And what it also gives us is if we have two functions, one on the prototype and one on the one on the character and one on the fighter, we can make it so that we decide which one gets used. So, for example, let's say a character would define a attack method, which would be like a basic punch that everybody can throw, but the attack method for the fighter would be like actual like sword slashing. So even though the character is the prototype of the fighter still can slash a sword instead of punching. So now instead of writing like it would be with arrays, where we would like the developer would have to remember whether this character can punch or he can also slash or he can cast a spell. Now all he says is attack, and the character itself decides what it wants to do. So this brings us closer to the great things that OOP allows us. So that what I just talked about is called dynamic dispatch and message pathing. So we can a lot of programming languages do it for us. They allowing us to dynamically choose which method is going to be run. This is how we have method overriding in PHP. So let's talk about encapsulation. With this, like if you look at the structures here, so that let me delete the wizard and everything else related. If you look at what we wrote in here, you might see that there is a big problem that all the data is accessible to everyone. Let's say we might have some transient, very delicate things here. For example, a fighter can have a particular amulet or a sword defined on him, like let's say like bonus that gives him like bonus to attack. Bonus 3. And like now we can see that strength and bonus are things that don't really matter to other functions apart from the one that does the attack. So only internal functions that are doing something with the data can actually do this, can actually modify it. So for example, let's say we have a function fight that takes one fighter, fighter A and fighter B. This function will only care about how hard they can attack, and it doesn't care about their bonus and strength and things like that. And this brings us to thinking that, well, perhaps if we could expose only a limited set of functions to the outside world, it would make us more flexible, because let's say we've been calculating strength, attack power using just strength a moment ago, and now we want to calculate the attack power with both strength and bonus and maybe something else. And if we used a strength directly in a lot of functions, it's just not going to account for that. We would have to go to all these places and fix the code there. But if we have a single method which would say function get attack attack bonus, or actually get attack score, which would return his plus his like bonus. If we had this function, and if we could guarantee that people will only use this instead of strength and bonus directly, then we can modify this function and code everywhere will just work. But now how do we ensure that? How do we ensure that nobody can access the strings directly and modify it directly? And that is what object-oriented languages allow us. We're going to get to those in a bit, but just to see, so you would see the benefits. So we also talked a bit about inheritance already, because you can really see that fighter inherits some structure from the character. And if you look at the JavaScript example, we have also fighter inheriting by prototype from the character. This allows us obviously to write less code because we can now write common code. Now, another thing is polymorphism. Polymorphism is, we also talked about that. See, this was the point of it. I tried to first talk about things and then explain them. So what is polymorphism? Polymorphism is, remember our wizard level up, character level up function. Level up function. This function that we had that did this function that we had here that leveled up character, it didn't care whether we were level upping a wizard or a fighter, because all it needed was character data. And that is polymorphism, where we can actually, well, not really, because we have to still call this function with like specifying the character substructure. But the idea behind it is the same. We write one code, and that code is reused for other descendants of the same structure, for like for other characters. So with arrays is a bit clunky. So then let's see how the PHP classes come in. So whoosh, we'll delete this, and let's start with our class character. And character is going to be an abstract class because it means that it could not be instantiated on its own, because a character doesn't really like, it has to be some kind of characters, be either a wizard or a fighter. It cannot be just a character. So the things that he would have, let's say he has a public name. Actually, let's talk about methods instead. Let's say that he has public function get name. He would have a public function get level, and he would also have one that would be called get money. All right. All right. Okay. Now, this is to allow the outside world to actually read the data from our structure, to know the character level and money. To actually store this, we need the data. So we would have protected $name, protected $level, and protected $money. What this means is, and now here, return this name. Now this already solved a lot of the problems I mentioned before. So the first thing is that now name, level, and money are not accessible by the outside world to modify. They can only be read with the methods. That is, like, we already encapsulated something in the class. But now let's go to the fighter. So let's go to the fighter, class fighter. Extends character, public function attack score. I'll use the style to save space on the screen, because if I put everything on a new line, I'll run out of space quickly, and I don't wanna have to scroll. So return $this strength plus $this bonus plus round 120. Alright, and this is, so he has to have protected $strength. Alright, so let's look here. So now we have fighter that inhabits the same get name, get level, get money from the character, and adds its own method to it. And now let's look here in the character. Remember when I said that a basic character should be always allowed to punch someone in the face? Well, let's put this here. Let's say so his attack score is going to be just like this random 20. Because there is no bonuses to it. Alright, so I have to scroll a bit. Actually, I can just reduce the font size for the entire thing to fit. So now let's look at this. So what we already did is that our fighter itself decides how it is going to attack. So even though a character can have an attack score of its own, it's the descendant class, the fighter, that says no, we're going to attack like this, and he can change that. We encapsulate the strength and bonus inside the fighter. Now the outside functions do not know this, how the attack score is calculated. That means they have to use the function that we defined for it, and that means then if ever we have to change the logic for the fighter, we can do it. So another great thing is, before this, and even in JavaScript, we were talking about concrete fighters. We created a concrete fighter that was called Yendor, and he had some money and some level. And now if we wanted to create more fighters that all have the same characters and same keys, it would require a lot of doing the same work again. So let me just go away a bit. With this. So if we look at our wizard, we see that the creating a new character is always a chore, because we have to actually define like the name, level, money as a separate structure, put it in a different structure, and then add the same stuff, and we always have to make sure that we're doing the same stuff over and over again. So classes actually allow us to not do all this work, because after we've created the class, which is like a blueprint for our objects, all we have to do is say like, hey, I want a new fighter, $fighter equals new fighter, and here we will pass his name like as constructor parameters. It's going to be Yendor, it's going to be level 7, it's going to have 15 of money, it's going to have a strength of 8 and bonus of 3. And then we can just use this code and create as much fighters as we like. And all this like data structure thingy that we talked about is going to automatically be created for them, courtesy of PHP and object-oriented programming. So a lot of people, so the answer to the question that a lot of people who've been doing programming with arrays and data, with arrays, data structures, like the struct types in C, and and the biggest questions they ask is, why do I want to do this in the OOP way? Like, why do I want to learn object-oriented programming? It's obviously a lot of clutter. Why? Like, because I have to like define classes and stuff, and then all these problems come in, that there's like also some patterns that you need to know. There's sometimes you want to inject some dependencies. There's all these different new things that this brings, and that it allows to improve the code further. So what would be, like, to recap, what would be the actual answer to a person asking why to use OOP? So the first would be dynamic dispatch, because we could modify the function attack score in the fighter itself, overriding the function attack score in the character. If we were using functions, we would have to always check if is a user a fighter. If the user a fighter, then use his strength in the bonus. Is the user a character? Oh, then just punch. Here we don't have to do it. Encapsulation, by hiding level and name for modification from the outside world and allowing only read access to it, we make sure that no developer by mistake later on renames the fighter in the game. Like, the fighter is fighting in Salini instead of Yender, he becomes Rodney. You know? And this also means that we can we can change some things subtly, like the attack score calculation for the fighter that depended on strength and bonus now can also depend on some magical characteristics and the enchantment on his sword and things like that, without changing this anywhere in the code. So by putting limits on what other parts of code can access, we are more flexible in modifying the actual code behind the fighter. So inheritance is the obvious benefit of not writing duplicate code, because we have a character, we inherit from the character, and everything a character could do, both wizard and the fighter could do, and we don't have to think about it anymore. Polymorphism. Same thing, but different. All the functions that could operate on character, let's say that we have like even the function fight, that would accept two characters and battle them based on their attack scores, doesn't it only depends on the parent being a character and having the attack score method. It doesn't care if it's a fighter or a wizard, which also makes us enables us to write less character specific code. So these are the things that I think are important to understand why we need OOP and OOP in general. And the last thing you have to remember is that classes are not really is not the same as OOP. In JavaScript here, we could do the same thing. We could define a function that would act as a constructor and build the objects, and there are no classes here. But you still can do a dynamic dispatch, encapsulation, composition, polymorphism, all that with JavaScript. And in fact, if you if you really want to try your wits, you can actually try and maybe even do this with. You won't be able to do it perfectly with arrays, but you could try and just how most of them done with functions. It would obviously require more work on your end. So that is all. Thanks for listening if you stayed until the end.